This is the fourth and final video for Chapter 1, Lesson 4, and I want to look at some inequality vocabulary as well as look at one of the applications of some compound inequalities, and that's tolerance. So first of all, to help you with some of these word problems, there's some vocabulary that's important to know. One of the words or vocabulary that we want to look at is greater than. In other words, when we're looking at problems, word problems, and we are reading them, we need to know what the words in the problem mean. They help us put together these mathematical expressions. So greater than, that's pretty easy. Whenever you read greater than in the problem, you're going to have something that's greater than something else. And so you have this expression greater than. Okay? Another phrase you might see in a word problem is the phrase less than. And again, less than, when you're looking at less than, that's pretty easy. Everybody kind of knows what less than means. You have something that's less than, and then you have something else over here. Some other words that you have to be careful of, or phrases that are a little bit more tricky and you got to kind of think about, is something that you see, something that says like at most. What does that mean mathematically? What does that look like if something is at most, 50? Okay, so something like you can go to the store, but you can spend at most 50 bucks. Okay, so what does that mean? Is that a greater than or less than? Well, at most means I can't spend any more than that. So at most actually means less than whatever this is. You can't spend any more than that. So that would be, or translate into a less than, or maybe to, or equal to, at most. Okay, another phrase that you'll see in word problems that again you need to know how to translate that will really help you. At least, if something has to be at least 7 feet, what does that translate look like in here? Well, that's going to be at least means it has to be at least this big or bigger. So the value that you're choosing has to be greater than or equal to. So these are some vocabulary words that you really need to be aware of as you're reading these word problems in your lesson. And if you understand these phrases, that'll help you set up something as you go. Now, one other application of absolute value inequalities are what we call tolerance. And tolerance is, we'll deal a lot more with this, or another case when we deal with the absolute value inequalities in the next lesson. But tolerance is how far something can be off its actual measurement that you're desiring it to be. In other words, when you measure something, let's say I'd like to cut a piece of lumber and I want it to be 3.5 feet long. Well, if I had 10 different people cut 10 different pieces of wood, would they all be exactly 3.5? No, some might just be a little bit longer, some might be a little bit shorter, but as long as it's kind of close, I'm okay. But how close is close enough? And that tolerance, what I'm willing to accept of being over or under, that's what tolerance actually is. So you can kind of think of it as this way. It has to be at least this length, okay? And then in here, this is X, this is what I actually want. Or it can be at most this length. Okay, so I really want it to be here, but if you cut it a little bit short, I'll take it. If you cut it a little bit too long, I'll take it as well. Now, if you cut it too over this, over my tolerance, then I'm not going to accept the piece of lumber, whatever it may be. So, for instance, one of your problems says that we want an ideal length of 13.48 centimeters. And I'm willing to accept, or it can vary, by at most 0.03 centimeters. So I'll take 0.03 over this, I'll take 0.03 under it, but anything over that I won't. So how do I write that as an inequality? Well, my minimum at least is going to be what I want minus, this is going to be desire, minus my tolerance. How much will I take? And that's going to give me what we're going to call the minimum amount that I'll take. At most, I'll take my desired, what I really want. I'll go ahead and add in my tolerance, what I'm willing to accept over, and that's going to give me the at most, or that's going to give me my max. So it has to be somewhere in between. So here's what I want. It's my desire. I'll go 0.03 over, or I'll go 0.03 under. All right, so what's my inequality? So it's x, and over here is going to be what I want, minus how far off I'm willing to let you cut it. And over here, I'll take my what I want, and I'll add to it what I'm willing to take over. So I just go ahead and do that arithmetic here. So 13.45 less than x less than 13.51. So I'll take anything between 13.45 and 13.51. So this would be the compound inequality. Notice it's an and inequality. That would represent the tolerance that I'm willing to take. And again, we'll do a lot more of those when we get into absolute value and see how absolute value applies to that. So why don't you go ahead and do number 26 in your book and do number 28 in your book. So number 26, I'm going to go ahead and walk you through. Baker needs 40 to 50 pounds of a flour-sugar mix. Well, if I'm going to mix flour and sugar, I'm going to add flour and sugar together. So I'm going to add the flour plus the sugar. And when I get done, I need to have at least 40 and no more than 50. It needs to be between 40 to 50 pounds. Now the problem I have here is I have two variables, f and s, so I can't solve it until I have just one variable. So I need to define one in terms of the other. What I mean that is I need to take this expression right here and to translate it to give each one a variable, and then describe the other one in terms of that same variable. In other words, whenever you have an expression like this, I'll take sugar and I'm going to let sugar equal s. Okay, so this is going to be s. Now flour, f, so we're going to let our flour, which I can say consider f, is 10 times the sugar, so 10s. So if I put in 1 pound of sugar, I got to put in 10 pounds of flour. So f is actually equal to 10s. So I can take this 10s now and put it in for s, and give, or f, excuse me, and then I have an equation or an inequality that has all the same variable in it, and now I can go ahead and solve this. So 40 less than 11s less than 50, and then I go ahead and divide by 11. So I'm just going to leave it as 40 divided by 11 for right now, and 50 divided by 11. So that's what s is. But what is s? S is sugar. Well, if I go back, it wants me to ask the possible weights of flour. Okay, so flour is going to be 10 times whatever my sugar is going to be. So my sugar is going to be between here and here. So my flour is going to be the sugar times 10 times. Okay, or if I'm putting this much sugar in, 10 times that. So then I can go ahead and simplify this. So this is 400 over 11, and then flour, this would be 500 over 11. Excuse me, I'm getting a little messy here. If I go ahead and calculate that out, then my flour needs to be somewhere between 36.4 pounds and then 45.5 pounds of flour. That's how much I'm going to have to use when it comes to that. So that's how you do it in number 20. This is number 28. I'm given a metal rod that's 4.78 centimeters, and I need to cut it down to 4.5. Now, I can cut it to 4.5 as long as I stay within 0.02 centimeters either way. That means I can cut it 4.5 plus 0.02, a little bit over 4.5, or a little bit under. So what would that be? So I need to cut 4.5. What's the maximum or the longest it could be? I would add the tolerance to that. So the rod needs to be between, if I add 0.02 to 4.5, just doing that right here, 4.52, then my rod can be 4.52 at a maximum. That's going to be 0.02 over 4.5. Now my minimum, remember, is my desired minus 0.02. Be sure you line up those. That's 8, 4. So my minimum is going to be between 4.48. So whatever I end up cutting off, I need to have it between 4.48 and 4.52. Now the question is, how much do I need to cut off? So I need to know, well, I'm starting with 4.78, so if I cut it down to 4.48, how much did I cut off? So we just go ahead and subtract that. 4.48, take that 0.3, so I could cut as much as 0.3 off, okay, Or if I got 4.78 and I cut it down to 4.52, if I subtract those, that's 2, excuse me, 0.26, I could cut off as little as 0.26. So I'm going to cut off anything between, as long as it's more than 0.26 but less than 0.3, I'm going to be okay. I'm going to be at 4.5 plus or minus 0.02.